Welcome back to Math 103 College Algebra from Central Connecticut State University. This is night 2, second night of the class. We're going to look at section 1.2 from our text. Pretty much just looking at a few different things here. The title of section, Visualizing and Graphing Data. We're going to look at a few things here. First, I have a set of data. If I look at one variable data, sometimes it's called univariate data. Suppose I have 10 students in a math class who receive the following grades on a test. You can see the scores of 75, 63, 84, 92, 84, 88, 78, 92, 68, and 80. Notice the data only has one variable. It's a grade on the test. Because we're only looking at the one variable, that data, we consider that univariate or one variable data. If I want to put the numbers on a number line, and I didn't leave myself a lot of space here, but that really shouldn't be too difficult. Okay, put my numbers on a number line, and I want to look at, notice the second bullet here says to find the minimum and the maximum scores. That would actually help before I put the numbers on a number line, but I notice I have a minimum score of 63 and a maximum score of 92, which of course shows up twice. What I might do is on my number line here say I've got 60, 70, 80, 90, and 100, and evenly space those. Then I'm going to pick a different color here. Let's just use, I guess this green for looking at the data. We have a 75, which is here, 63, 84, 92, 84. And what I'm going to do is I'm going to list that number twice there. We've got an 88. And notice that I'm putting the number there as well, because I'm not confident that I'm getting that line in exactly the right place and that someone would be able to read from my drawing the exact numbers that I have. So I'm going to label those, and I've continued to go. As I've talked with you, I've got the 8 scores on a number line. It's important, I believe, that the spacing from 60 to 70, 70 to 80, 80 to 90, 90 to 100 is as consistent as you can be. Okay. When I go to find the mean and the median, if you recall, the mean of the scores is if I take the sum total, I add them up and divide by how many there are. The median would be the number that is in the middle. I'm going to encourage you to use technology as it's available. And the technology that we have available with the grapher, if I go to Stat, Edit, and I see L1 here, and I can at this point just type in the data values that we have. We have 75, and I'm just going to type the number 63 and then press enter to enter that number. 84, 92, 84, 88, 78, 92, 68, and 80. It's always a good idea to look back at your data to make sure that you've entered it correctly. 75, 63, 84, 92, 84, 88, 78, 92, 68, and 80, and I've found those correctly. Stat, calculate. Notice number 1 is 1 var. That means it's one variable statistics. We mentioned that this data is one variable data, so I'm going to press enter. The data is in L1. Each piece of data counts once, so I don't have a frequency list. I'm going to leave that blank. Calculate. The X bar is the mean. So the mean, X bar, the mean is 80.4. Then you notice that there's a down arrow here. If I keep going down, see the median is 82. And just a quick recap of what that means is, suppose that these 10 students decided that they're going to share their points equally. So they take the 75, the 63, the 84, 92, and so on, and they add those numbers up. That's a total. You see this second line here, the capital sigma x, 804. Together, the 10 people earned a total of 804 points. So if I take that total of 804 points, and I divide that evenly among the 10 people, each person would get 80.4 points, and that's the mean. The median would be the person in the middle. So half of the students scored more than 82 points, half got fewer than 82 points. And so that's just a quick look at univariate data as far as we need for this course right now. If I look at the next section, last 5 paychecks my son received from his job. Okay, he worked 78 hours, is over a 2-week time period. $78, he made $1,404. $73, $1,314, and you can see those data points. Now you'll notice that we have an independent and a dependent variable. The independent variable is the variable that you have control over. The dependent variable is a response to that. So the independent variable is hours worked. You can control that. If you call out sick, you work an extra day, you go home early, you can control the number of hours that you work. The dependent variable would be your pay, in this case, your gross pay, because that's a result of. You can't tell your boss, hey, I just want more money, and he gives you more money. To get more money, you work more hours, or fewer hours to get paid less. The domain of the function is the values that hours worked can be. So if I'm talking about over 2 weeks, I would say the domain X has to be between 0 and 80 hours, assuming that the boss is not going to pay overtime. The range of that function, let me come back to the range of that function because that would be the amount of money that you might get paid. Now, when we look at the relationship between the domain and the range, what I think I want to do is say, well, let's think about this. If I worked for 78 hours and I get paid $1,404, how much is that an hour? I'm making $18 an hour. Let's look for consistency. 1314 divided by 73. 1314 divided by 73. Let me do this one more time. 1314 divided by 73 is $18. So let me turn it around. What if I did 71 hours worked times $18? That would be the 1278. So it appears that my son is making $18 an hour. So my relationship is y equals 18x. For each hour worked, x, he gets paid $18. So my range, well, if he works 0 hours, let's do this, right, just to be funny, 0 times 18, 0 times 18, he makes $0. But if he works 80 hours over the 2 weeks at $18 per hour, he could make up to $1,440. So that would be the range. Okay. You can do that with the calculator as well. Just a quick recap on how to do that. I've got another video in here. I can put a link in the description to linear regression. But as a quick version of that, if I go to Stat, Edit, clear my L1, and if I put in my X values, my hours worked, 78, 73, 71, 80, and 84, and my Y values are 1404, 1314, 1278, 1440, and 1215. If I go to Stat Plot, turn that plot on, linear regression right there, L1 and L2. For marks, I like to use pluses. I find that the squares are just a little bit too big, the dot's too small, and the plus is just right. Then I'm going to hit a zoom. Number 9 is zoom stat, and this is way off. I think I put in a piece of data wrong. 84, 1215. Actually, I think that 1215 might be a typo. I think that's supposed to be 1512. Let's fix that. Now, the reason I say that might be a typo is I'm expecting that he's making the same per hour. So this number being this low makes me think that something's off. So let me fix that number. 1512. Now graph that. Whoops, zoom 9. Now that data appears linear. Okay, so that's how I can plot that regression there. Okay, so a couple of other things that we're looking at in this section. Like I said, this section we're starting off this course with just hitting a few basic topics. The distance formula. The algebraic representation of the distance formula and the geometric representation of the Pythagorean theorem are essentially the same thing. If I think of the point 25 and the point 712, 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4. So here's the point 25. And let's pretend I counted that out. There's 7, 12. If I want to find this distance, the horizontal distance is the difference between 7 and 2. The vertical distance is the difference between the 12 and the 5. 7 minus 2 is 5. 12 minus 5 is 7. So this distance is 5. This distance is 7. The Pythagorean theorem says that the leg squared plus the leg squared equals the hypotenuse squared. The distance formula says that the difference in the x values squared plus the difference in the y values squared, square root of that sum is equal to this distance. And it's the same thing. So to find the distance from this point here, point A, to point B is 7 minus 2, 5 squared, 12 minus 5, 7 squared, and then that distance, we're going to take the square root. So 5 squared plus 7 squared. So that distance is the square root of 74. And I'm okay leaving that the square root of 74. So to do this just algebraically without drawing my messy picture, the distance between point A and point B, I'm going to find the square root of 6 minus negative 5 squared plus negative 8 minus 3 squared. 6 plus 5 is 11. And 11 squared is 121. Negative 8 minus 3 is negative 11. And negative 11 squared is another positive 121. What I suggest that you do is say that this is 121 times 2. So I have the square root of 121 times the square root of 2 is 11 times the square root of 2. And so there's the distance there. Now, if I have something gross like number 3, we tend to freak out a lot of times and say, oh, I don't know, no, there's fractions. What do I do with the fractions? But the distance, if this is point A and this is point B, it's really the same thing. 7/4 minus 2/3 squared and 8/5 minus 5/2 squared. And I'm going to do this with the fractions, I think. 7/4 minus 2/3. 7 times 3 is 21. 4 times 2 is 8, and it's a minus. 4 times 3 is 12. So that's 13/12. Now, if you don't like that, with the calculator, you could do 7/4 minus 2/3, and you're going to get a decimal. If you hit math number 1 changed to a fraction, press enter, you get the 13/12. So you can handle that either way. You could also go to alpha y equals, choose number 1, and it will give you a fraction already. 8 fifths minus, not math, alpha y equals number 1, 5 halves. And that's negative 9/10 squared. So you could do all of this. Also, if I'm going to use the calculator, let's just go ahead and do 13/12 squared plus negative 9/10 squared. Decimal, I'm going to change that back to a fraction. 7141 over 3600. Of course, if I'm going to take the square root, take the square root of that previous answer, if I try to change that back to a decimal, I bet it's not going to do it. 1.41 is close enough. So if I'm going to go to a decimal, I probably could have used the calculator right along. Anyway, but my point here is even though there are fractions, notice that the distance formula is the same process. Okay. Last quick topic, midpoint formula. Midpoint formula is the point in the middle. What's halfway between 2 and 7? 2 plus 7 is 9, and halfway from 9 is 2, so 9 halves. Halfway between 5 and 12 is 5 plus 12 divided by 2, so that's 17 halves. So your midpoint is simply 9 halves, 17 halves. If I want to find the midpoint between these 2 points, negative 5 plus 6 over 2, 3 plus negative 8 over 2, negative 5 plus 6 is 1, 1 divided by 2 is 1 half, 3 minus 8 is negative 5 divided by 2 is negative 5 halves. So there's the midpoint, halfway between those 2 points. So for number 6, if I want to find halfway between those, and there's fractions, you can do the fractions on paper. You have availability of the calculator. If you want to use the calculator, you need to do it correctly though. 2/3 plus 7/4 divided by 2. The way I'm going to recommend that you do that on the calculator, if you don't like the alpha y equals, I prefer doing this. 2/3 in the parentheses plus 7/4. I needed to put that in the parentheses. Enter, divide by 2. Math, enter, change it back to a fraction, and that's 29/24. 7/4 plus 8/5. Enter. I'm going to divide that by 2 and change it back to a fraction, and I get 67 over 40. It's the same process. I use the calculator because that was a lot easier. You notice here my notes graphing with the graphing calculator. I'm going to leave that for a future section. Okay, so this is the second night, College Algebra Math 103 at Central. Just a few different topics to hit as we get warmed up and get ready for the semester. I trust that this is hopeful, and I will see you next time. Please don't forget to subscribe.